Hi everyone, welcome to this tutorial. I am Shubhendra and I'm a developer advocate. Today we are going to build something exciting that is an AI agent using Tavily and LangGraph. Now you have probably heard about chatbots and LLMs, but an AI agent is different. It doesn't just respond, it takes actions, plans steps, and uses tools to solve problems. So basically you're giving your AI superpowers, and one of the coolest use case is fact checking. LLMs like Gemini are powerful, but they sometimes hallucinate and make things up. By combining LLMs with Tableau's powerful search API, we can ground these responses in real-world evidences. So by the end of this video, you'll have a fact-checking AI agent that takes in a claim, uses Tableau to search for evidence, lets Gemini analyze the results, and finally gives you a verdict, true, false, or partially true, along with the sources. So without further ado, let's dive in. Now, before we begin, I would like to give you a quick introduction to Tavily, LangGraph, and Gemini. Tavily is a developer-first search API that's designed specifically for AI agents. Instead of just running a bunch of raw links like Google, Tavily gives us clean, structured, and trustworthy search results, perfect for fact-checking and reasoning tasks. Now, the LangGraph, on the other hand, is a framework for building stateful AI agents. Instead of writing long, complicated if-else chains, LangGraph lets us define our agents as a graph with nodes for different steps, memory for conversations, and even advanced features like human in the loop or time travel. And finally, Gemini, Google's latest family of large language models. Gemini powers the reasoning in our agent. It takes a claim, reviews the evidence from Tavily, and generates a clear verdict. So to summarize, Tavily helps our agent fetch real evidence from the web. LangGraph helps us structure the agent as a stateful graph, and Gemini is the reasoning engine that ties it all together. Now let's go and grab the keys for Tavily and Gemini. To get the keys for Tavily, we'll head over to tavily.com. I've already created my account on Tavily, so I'll simply log in. After logging in, you can see that the default API key is already generated. If you don't want to use a default API key, you can go ahead and click on the plus icon to generate a new key. So for free plan, Tavily provides 1000 credits, which is good enough for development purpose. Now, as you can see that we have created a new API key. You can simply copy it from here. Now that we have API key for Tavily, we'll just go to Google AI Studio and grab the key for Gemini. I was already logged into Google AI Studio, so it just redirected me to the dashboard. I'll just go ahead and grab the API keys from here. If you don't have any API keys generated, you can click on the Create API Key button and create an API key for you. Now that we have both the API keys, we can go ahead and start setting up our project. Now let's set up our project. I'm using VS Code, but you can use the editor of your choice. I have a terminal open inside my VS Code, and the first thing we'll do is install the required Python packages. So this is the command for installing the required Python packages. The first one is LangGraph. This is the core framework we are using to build our agent as a graph of nodes. It gives us tools for state management, memory, conditional edges, and so on. The another one is LangChain. LangGraph is built on top of LangChain. It uses LangChain's messages format, tools, model wrappers under the hood. So we install it because LangGraph depends on it. The another one is LangChain Tavily. This is the connector that lets us call Tavily search API from inside LangChain or LangGraph. Instead of writing a raw HTTP request, this package gives us ready to use Tavily search tool. The another one is LangChain Google Gen AI. This is the connector for Google Gemini's models. It lets us use Gemini's chat models and directly talk to Gemini through LangChain. And the last but not least, python.env. This is just for convenience. It lets us load API keys from a .env file instead of hard coding them in our code. Okay, so now let's store our keys securely using a .env file. Create a .env file at the root of directory which we'll use to store the API keys. This way we don't hard code secrets into our code, which is a best practice. Okay, so before we code, let's visualize how the agent is gonna work. So you type a claim, Tavily searches the web and gathers the evidence, Gemini analyzes that evidence, and finally you get a verdict along with the sources. So our flow is claim, then search, then verdict, then output. And thanks to LangGraph, we'll model each step as a node in a graph, clean, simple, and extensible. All right, now we are almost there. Let's actually build our fact-checking agent. Create a new file in your project and name it as factchecker.py. We'll go through the code step by step. First, we are importing everything we need. OS and .env will help us load API keys securely from a .env file. Typed and annotated let us define what our agent state look like. From LangChain, we import the Gemini model initializer and Tavily search. From LangGraph, we bring in the building blocks for making our workflow, like state graph, start, end, and add messages. And finally, in-memory saver gives our agent memory so it can keep track of our progress. Now here we load our API keys using .env and setup memory. Here we are initializing LLM. I have used Gemini 2.0 Flash. You can use any compatible LLM of your choice. And initialize Tavily as our web search tool. I have set the max results as 3. By default, it's set to 5. You can look into Tavily's developer docs and how you can customize the search API. Next, we define our state. Think of it as an agent's notebook. It keeps track of the conversation messages, the user's claim, the search evidence, the final verdict, and the support sources. Each of these will be filled in as the agent moves through the workflow. And now here we create the graph nodes. The first node is claim node. It just captures the user's input, that is the claim we want to fact check, and saves it in the state. The second node is search node. Here we send the claim to Tavily's search API. We gather snippets of the content as our evidence, and we save the top 3 link as our sources. This gives our agent real world data to work with. And the final node is verdict node. We pass the claim and evidence to Gemini with a special system prompt that says respond with true, false, or partially true along with the explanation. Gemini returns the verdict along with the sources. Now we link everything together with a state graph. We are adding our 3 nodes here, claim, search, and verdict. And then we define the flow, start, claim, search, verdict, end. Lastly, we compile the graph with memory enabled. This gives us a clean, structured pipeline for fact checking. Now, finally, we create a runner function so we can test this in the terminal. It asks for user input, sends the claim through the graph, and prints the verdict along with the 3 supporting sources. This way, you can type any claim and immediately get a fact check results with evidence. And that's it. We are done with the code. Now all we have to do is run the script and test the agent flow. Now the moment of truth. Let's run our fact checker. I'll enter the command in the terminal to run our fact checker. Okay, so now it's asking for a claim. I'll enter something random here. Should share false. Okay, so as you can see, it has shared the output as false because Samsung Galaxy S25 Ultra was released in 2025. It has also shared the sources that was gathered by Tavily API. So this is really awesome. In just few minutes, we have gone from nothing to fact checker AI agent that can pull live information, check claims, and also share results. So that was it. If you have any questions or just want to say hi, feel free to drop a message on Tavily Developer Community Forum. We would love to see what you're building, and thanks for watching.